Logarithms. Before we get into logarithms, we're just gonna remind ourselves of what an exponent is. So for an exponent, you have a base. This is the important number, and you raise it to a power. Let's say a, and as a result of that, you get another number. Let's say c. So what that basically is you're multiplying the number b by itself a certain number of times, and that number of times is what you refer to as a. So like 2 to the 3. What does that equal? Well, that's just 2 times 2 times 2 multiplied by itself 3 times, and of course you're going to get what? You're going to get 8. That's what you're going to get. That's what exponents are. Now, what mathematicians wanted out of logarithms, they wanted like an inverse of exponents. And what an inverse is let's say you have a number like x and you put it through a function f. So what a function does is it manipulates this number x and turns it into another number. Let's say y. It turns it into y. But what an inverse function does is it takes y, it takes that end result, and it's like spits out the x basically. It just brings it through another function that gives you what you started with. See, it's kind of a bad example, but so you got a number, you put it into a function, you got a different number. Now that if you put this different number into an inverse function, you get the number you started with. So that's basically what we wanted out of logarithms. Let me clean up here. So a logarithm is going to seem arbitrary at first, but I'm going to write it down, just let it sink in. Log, this is how you write a log. Log base b raised to a number. I honestly don't know what to call it. I don't know how to say it really. Log base b to c. I think that's how it's said. And it equals a number. And I purposefully used these letters, the same 3 letters, to like show you how you can associate each of them with each other. So in an exponent, you have a base. You multiply it by itself a times, and you get another number. You get c. What a logarithm does is it takes the same number b, so you can see that it's focused on in both of these examples. It takes that base. You have the end result this time. This time what you don't have is the number of times you're multiplying b. You have the end result. So in this example, let's say you had the base, let's say 2, again, we're going to use 2, and you're given the number of times you want to multiply itself by. 4 this time, let's use that. That's all you were given. Let's say that was your first exponent problem. Well, what you're going to have to solve here is the missing value, the c, which is just multiplying it by itself 4 times. So that would get you 16. Let's say in a traditional logarithm problem, what would happen is, let me write it down, log, you would be given the base as usual, but instead you would be given the end result. So it's kind of like you have the number 2, you want to get to a number, but you don't know how you're going to get to that number. So, of course, in this example, 2 to the, you're going to have to say to yourself, 2 to the what power gets me 16? And that's, of course, going to be the same as here. It's going to be 4. So you see how they're really similar. It's just writing it in different ways. Okay, so I wanna correct myself from earlier. I was having trouble on how to say logarithms. So the way you would say it to maybe your teacher, you would say log base 3 of 27 equals what? This is my example. I'm gonna get into how to solve this. So you would say log base 3 of 27 equals what? That's how you would say it. Okay, so now let's get to the problem. So it says solve log base 3 of 27. There we go. Now I said it right. Log base 3 of 27 equals what? So obviously we're looking for this number here. So to remind ourselves, the way we would go about doing this in our head would be you would ask yourself 3 to what power gets me 27? Gets me 27. See, this is like the exponent way you would write it, right? This is how you're probably used to it. 3 to what power gets you 27? It's exactly the same thing as this right here. Log base 3 of 27. So, you probably know what this is. You know that 3 to the third power gets you 27. So yeah, you just solved the little question mark there. The answer to this is definitely 3. Okay, so we have another example here. So we have log base 4 of x gets us 2. And of course, we solve for x. And notice I switched out the question mark from before for an x, because I'm sure you're not going to have that many question marks in your everyday math problems. So, yeah, log base 4 of x gets you 2. So in your head, you would go by like thinking this as 4 to the 2 gets you x, because we established earlier that they kind of flip-flop, as you can see. Like the x and the 2, they kind of flip-flop when you flip-flopped when you compare the logarithm version to the exponential version. So from here, it's pretty straightforward. X equals 16. Okay, so in our final example here, we have it so when we have to find x when it's the base. So log base x of 9 equals 2. So what would we do here? As usual, we would think of it as like the exponent form, because that's easier to think about it in your head. So x to the, yep, we kind of flip-flop these. So x to the 2 gets us 9. So now this is pretty straightforward. We know that 3 to 3 squared gets us 9. So that's pretty much it for my logarithm basics video. Hope you guys watch another video. I'm going to be making some more. I'll see you next time. Bye-bye.